Hi, and welcome to Mighty Math, the channel that makes all kinds of nice mathematical concepts accessible, understandable, and lovable. On one of my previous videos, I worked out how many players should have survived Squid Game's glass bridge horror. On that video, I argued that these two expressions are equal. The left is what we calculated for the average number of steps a player gives information about to the rest of the group, and the right is the classical infinite sum, which actually stands for another approach to the same calculation. On this video, I'd like to very nicely show that the two expressions are indeed equal. Understanding what I'm going to show does require some basic knowledge in calculus and geometric sequences, but really basic, promise. Consider the function f of x equals 1 plus 1/2 times x plus 1/4 times x to the power of 2 plus 1/8 times x to the power of 3, and so on. If we place 1, we get 1 plus 1/2 times 1 plus 1/4 times 1 to the power of 2 plus 1/8 times 1 to the power of 3, and so on, which is actually 1 plus 1/2 plus 1/4 plus 1/8. This is our classical infinite sum, and it equals 2. I'll even show that in a little while. Now let's derive this function. We get 1/2 plus 2 divided by 4 times x plus 3 divided by 8 times x to the power of 2 plus 4 divided by 16 times x to the power of 3, and so on. If we place 1 in the derivative, we get 1/2 plus 2 over 4. We can ignore all the ones. Plus 3 over 8 plus 4 over 16 plus 5 over 32, which is actually the expression we worked out for the average number of steps a player gives information about when trying to cross the glass bridge. Showing that one expression comes from placing one in a function and the other from placing one in its derivative obviously doesn't prove anything, but the function we started out with is not some junk function I picked up on some Black Friday sale. This function is actually the sum of a geometric sequence with a first term of 1 and the ratio of 1/2 times x. For a ratio smaller than 1, the sum of a geometric sequence converges and it equals the first term divided by 1 minus the ratio. In our case, r is 1/2, smaller than 1, because we place 1 for x. So instead of the long f of x, we can write 1/2 divided by 1 minus 1/2 times x. We said before 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 and so on equals 2. Now we can see that it really is by placing 1 for x. But now, abracadabra. If our sum 1/2 plus 2 over 4 plus 3 over 8 plus 4 over 16 plus 5 over 32 and so on is the derivative of f of x when placing 1 for x, then we can also derive the expression for the infinite sum of the geometric sequence instead of the derivative of the infinite f of x. We get 1/2 divided by 1 minus 1/2 times x and all of that to the power of 2. Now all we need to do is place 1 for x again and we get 2, just like the other sum. Pure magic. I hope you enjoyed this video and I hope you love math, because when you love math, math loves you back. If you hate it, it hates you back with a vengeance. Please make me a happy man by subscribing, a like, perhaps a comment. Until next time, bye bye.